In this video, I'm going to work through a number of examples solving quadratic equations via factoring. So I've got the procedure outlined here. So whenever you're solving a quadratic equation with factoring, you're going to put 0 on one side. All right, so move all the terms to one side of your equation and do so in such a way to make the coefficient of x squared positive. Okay, now we're going to concentrate in this video where the coefficient of x squared is 1. All right, so you want it to be positive 1 on one side of the equation. But regardless, you're going to do that, and then you're going to factor the resulting polynomial. That always means factor completely, so if you can pull out any common factor from each term, you're going to do that, and then factor the resulting trinomial, or typically a trinomial, or quadratic expression of degree 2. Then, once you have it successfully factored, if it does factor at all, you're going to set each factor equal to 0, and then apply the zero factor property to solve the resulting linear equations. Okay, now this might work, this might not work. All these examples we're going to look at in this video, we can solve by factoring. We will come across some, though, where this approach will fail. We'll have to use either completing the square or the quadratic formula. Okay, so let's take a look at this first example. So you want to move the 8 over by subtracting 8 from each side. Then rewrite your equation. It's x squared plus 2x minus 8 equals 0. And then we try to factor. So we look at the factors of negative 8 that add up to positive 2. Okay, and we know that negative 8 can be written as 4 times negative 2. Okay, that minus sign shouldn't be there. All right, so it should be positive 4 and negative 2. All right, and those are going to be what we're going to use to express our polynomial x squared plus 2x minus 8 as a product of two smaller polynomials, lesser degree, as x plus 4 times x minus 2 equals 0. And then we're going to use the zero factor property. The multiplication is in between the factors x plus 4 and x minus 2. Setting each one of those equal to 0, we get that x is negative 4 and it is 2. All right, so again, that's applying the zero factor property. Two things can multiply together to give you 0 if and only if one or both of those expressions is equal to 0. Looking at the second equation now, our constant term is 15, which is 5 times 3, and 5 times 3 adds up to positive 8. So we're going to rewrite our polynomial x squared plus 8x plus 15 as the product of the two linear factors x plus 5 and x plus 3. Still, remember, we're setting that equal to 0, so we can make the conclusion that two things multiplied together can be 0 if and only if one or both of those factors are 0. In this case, x plus 5 could be 0, or x plus 3 could be 0, giving us x could be negative 5, or x could be negative 3. All right, so for this quadratic equation, we're seeing we have two solutions. Okay, negative 5 and negative 3. All right, now I'm going to clear this off, and we're going to look at the third example here. So for this one, again, we don't have 0 on one side. We need to subtract 5 from both sides to put 0 on one side, all the other terms on the other, keeping the coefficient of x squared positive, which we've done here. Then we look at the factors of our constant term, which are negative 5 and 1, that add up to our coefficient of x, which is negative 4. And that tells us we can re-express our polynomial as the product of x minus 5 and x plus 1, those two linear polynomials. Then we set each factor equal to 0 and solve the resulting linear equations. And they're very easy to do in this case because that coefficient of x squared is 1, so it makes factoring it quite simple if it does factor. And these all do. And then you got a very simple linear equation, pair of linear equations to solve. So we get 5 and negative 1 as the solutions to that equation. Now, this last one, it's x squared plus 6x equals 0. There is no constant term. So this one almost trips people up more because the c term, the constant, is 0. The b, the coefficient of x, is 6. Now, it doesn't mean what we talked about before, looking for factors of c that add up to b. It doesn't mean that doesn't work anymore, because you can write 0 as 0 times 6. But it's not necessary in this case. It's easier to solve this equation almost because you can just directly factor out x from each term. Okay, and then you're left with x times the quantity x plus 6 equals 0. Okay, but notice that does line up with writing it as x plus a number times x plus another number. It's just x plus 0 times x plus 6. But there's no sense in writing x plus 0. Anything 0 plus anything is that thing itself. So now we can just set each factor to 0. We get x equals 0 and x plus 6 equals 0. And therefore we get our two solutions by solving each of these equations. X is equal 0 or x is equal -6. Okay.